Hey everyone, here is a little Titanic. So remember, how do you upload it? Well, look at here. We're going to do Titanic Survival. Make sure they're in your documents. Then you just hit here, import data set. We're going to take a look at it. Retrieving interesting data set on the real survival of the Titanic. Survived, sex, age, passenger class, first, second, third. So what we want here, this is called logistic regression because we have different types of variables here. We have nominal variables, sex, female, male, right? No order, survived, yes or no. That's it. So don't forget, we come down here, we attach it. Titanic survival. Here we go. Now this is called logistic regression because notice they're just nominal variables. In this case, binary variables, yes or no for the dependent variable, the result, and then the causal variable, did sex actually have an influence over who survived? So we're going to do this really quick with what we call the GLM function. So we're going to call it hidden iceberg, right? Iceberg, right? Same setup. So this is, instead of LM, it's the generalized linear model, GLM, no package needed or anything. So now remember, same situation, survived versus sex. A little different here. This has to be a factor. You can do it outside the, function or inside. This is the best way. You just go as dot factor. Right? So, but you need to have it in, so we're going to make sex a factor, go outside, T tilde, then sex is, oops, this is supposed to be survived. See that? We all make mistakes, so don't freak out. There it is, survived. So survive, the dependent variable, the result has to be a factor. So you have to go in GLM as factor, survived inside. Notice this is how coding works. So this is the name iceberg. This is the function GLM. Then you have as factor, making the dependent variable into a factor. Then T tilde sex. And what's interesting this, we're going to do the family binomial. Remember what binomial means. Binomial means just two, then comma, and then we can do data equals Titanic survival. There it is, the data. So the family's binomial to let the function know that this is either yes or no. That's by 2. So then we're just going to hit the button. It's kind of easy, and boom, iceberg. Then the same thing, summary. This is logistic regression. We're getting the log odds here. Really interesting, huh? Oops, iceberg down here, not ice cream, boom. So this is a big real data set of the Titanic. Isn't that interesting? Check it out. 1,309 people we got there. Let's just make it big here so you can see it. So it's really interesting. Iceberg, we did this at GLM, same setup as factor survived. It has to be a factor. Sex, family equals binomial, data equals Titanic survival. Now, you could do this as factor survived or turn the survived into 0 or 1. I would always do die 0, survive 1. So this logistic regression is with anything where you have a dependent variable, win, lose, die, survive. They're just two factors in the two attributes here. Whoops, what happened to my little thing? 2 attributes, what happened to my Titanic survival, in this. So it's either no or yes, whether you survived or not. That's what makes it binomial and logistic regression. So let's take a look at the results. So it has normal stuff. That's log odds. It's a little different, but look at male is against the base, which is female. So you are significantly, look at minus 2.4 log odds likely to die, not survive, because it's negative. If you're male, the standard of error is low, like we talked about. Look at the z-values. Z-values are used with very large N data sets, which is here, over 1,300. So it's negative 17.832. That's a massive number. You know right here it's statistically significant, as we went over before. You've got the 3 stars, it's under 0.05 using scientific notation. What's different about this, instead of the R squared, we have the null deviance. So the null deviance are the results without the independent variable. If we bring the independent variable in, this goes down significantly from 1,741 to 1,368, indicating that, see how there's one less degree of freedom here? Because with the independent variable -1, so you have that really interesting result. Anything, as I said in other videos, with the word error, oops, here, I can do my little pen even to do this. So anything with error or, let's say, residual, the lower the better. So you start looking at these, right? And you see it, and the residual is significantly lower here. A lot of people ask, how low does it have to be? Well, that's a tough one, but that's pretty low, right? That's over 400. So, and then this is really high. This is really low. The error is really low. And then this is, significantly high as an estimate. You're getting the log odds of being male because the female is the base. So this is the male. Why is female the base? F becomes before M. So it's A, B, C, D, E, F, G, H, I, J, etc. That's logistic regression. And this has real value because think about it. This is a real data set. You're seeing if gender was correlated with survival, and it clearly is. So you start seeing it and you say to yourself, you were more likely on the Titanic to die if you were male than you were female. Now, why is that? So this is where you show statistics is important and statistics is actually fun, because you have to ask yourself, why is that? Now, some of the students noted that it's because they thought other rescue boats were going to come and take people, and they said, okay, the women, children first. We don't know if that's true, because when we start for the next video, look at passenger class, which is not just a binomial male and female. The dependent variable is binomial, yes or no, but passenger class has third, second, and first. If that were true, that the men were just waiting for, rescue ships, however they did back then during the Titanic, then would passenger class be statistically significant? Well, that's pretty interesting. I guess maybe chivalry will never die. So on the Titanic, we can conclude you were more likely to die if you were male than you were if you were female. This shows the fun kind of approach to statistics, taking a data set like the Titanic, and we can apply this to a broad range of different interesting cases to see the variables that influenced survival. The next video will not have sex, male or female, but passenger class. What do you think will be the answer? This is logistic regression using the GLM function and the Titanic data set. Take care, everyone.